Good morning, Year 12 single mathematicians. We have finally made it to the end of Chapter 11, what would be the end of Year 1 mechanics. We're going to finish off with 11.5 constant acceleration. This was one of the the first things we did in mechanics was solve that, and we are returning back to that in the final lesson as well, just to show that everything ties up in the end. So the learning objective today, though, is to use calculus only to derive the constant acceleration formulae. In other words, deriving suvat. And yeah, we're going to restrict ourselves to just using integration and differentiation today, and not actually state these suvat formulas when working anything out. It's just an alternative way of doing stuff, and sometimes an examiner can state don't use the suvat formulae, use calculus instead. So we're going to start off with a constant acceleration, because this is where the suvat formulas come from. So we will assume the acceleration is constant, and we will assume, we'll call that acceleration A, and we'll assume the initial velocity is V. Sorry, doesn't make sense. U, it's better. Is U. Okay, so that's all we need to start off with is a constant acceleration A and an initial velocity U, and we can derive everything. So, for example, we know that to get velocity, we integrate. So velocity at any point would be integrating the acceleration with respect to time. And when we integrate, this would go to AT, but when we integrate, remember to include the plus C. There's the plus C. And there's enough information in what I've written above for you to work out what that plus C is. And it's based on this. Initial velocity is U. And what that means is when t is equal to 0, the velocity is equal to U. So replace V with U, replace t with 0, and we got the plus C, and then that C gives us U. So in other words, V is equal to AT plus U, which looks quite similar, and it is exactly the same as V is equal to U plus AT. So there's one of them. Let's see if we can get any of the others. And if you've got the formula for velocity and you want to work out the formula for displacement, then you integrate again. So displacement is integrating velocity with respect to time, and that's integrating that formula there, U plus AT with respect to time. U is a constant, A is a constant, so when you integrate this, it would go to UT plus a half AT squared. But remember, when you integrate, to include the plus C, and now there's enough information in the question for you to work at this. Initially, when t is 0, we assume s is 0. We assume it starts where it starts. And if you substitute that in, you get 0 equals u0 plus a half a0 squared plus c, which gives you c is equal to 0. In other words, s equals ut plus a half at squared. and that is another one of the formulas generated. And you could generate the others using other means as well, but we've just used calculus integration in particular to derive v is equal to u plus at and s is equal to ut plus a half at squared, purely from acceleration being a constant. And I'm going to do the next example using just calculus, just integration and differentiation, nothing else. And the exercise that you will do requires you to just use calculus as well. So we've got a particle moves in a straight line with constant acceleration. The initial velocity of the particle is 5 meters per second, and after 2 seconds it is moving with velocity 13 meters per second. Find the acceleration of the particle. So acceleration many ways to do this, but we're going to try and do it without quoting any formulas at all. So just call the acceleration a, and we are going to work out everything to do with velocities. So let's find the velocities. So that would be integrating the acceleration with respect to time, which would be v is equal to at, but remember the plus c. And then we've been given a few things in the question. We've been told initial velocity is 5, which means if we substitute t is equal to 0, then v would have to be equal to 5. So that would give us 5 is equal to a0 plus c, which would give us c is equal to 5. So in other words, v is equal to at plus 5. And we're also told that after 2 more seconds, the velocity is now 13, which means 2 seconds later, t is equal to 2, v is equal to 13. And if you substitute that in, you get 13 is equal to a times 2 plus 5. And if you make a the subject, so we get subtract 5, you get 8 is equal to 2a, which gives you a is equal to 4 meters per second squared. And I managed to work out the acceleration using just integration and differentiation, no SUVATs at all. Okay, part B. This is what a question would be worded like if you couldn't use SUVAT. So it says, without making use of the kinematics formulae, that's the fancy word of no SUVAT, show that the displacement s of the particle from its starting position is given by this formula, where p, q, and r are constants to be found. So I will need to use something from the previous question. If you remember, I had a formula for velocity there, which was almost finished. So that formula for velocity is at plus 5, and I worked out a to be 4, so that would be 4t plus 5. And then to get displacement from that using just calculus, you'd integrate. S would be integrating v with respect to t, and I'd be integrating 4t plus 5 with respect to t, which goes to 4t squared over 2 plus 5t, but remember the plus c. So s would be 2t squared plus 5t plus c. And there should be enough information in the question for us to find out what the plus C is. I think it's pretty much this wording from its starting position there. So what that means is when t is 0, we assume it's at the starting position, which would be s is 0. So if you substitute those in, you get 0 equals 2 0 squareds plus 5 zeros plus c, which gives you c is equal to 0. And when c is equal to 0, you get s equals 2t squared plus 5t plus 0, which would be it. And that would be the formula. So yeah, it's quite a interesting one, this one, because you have to restrict your methods down to just calculus. But it is worth practicing because they can insist on you just using calculus. So I would like you to try exercise 11E, which is on page 192, but try the even questions only. Evens only. Really important that your method is correct for this one. So make sure you upload pictures of your workings to the class notebook, so I can just check to see if you're doing it right and you're not being lazy and just using Suvat. If you have any questions about this, then please post them in the Teams chat and I'll get back to you. And yeah, that is all of Year 1 Pure Maths and all of Year 1 Mechanics that I need to covered at least once. And for the rest of this half term, we will revise for the internal exams, and then after the half term we will move on to some Year 2 stuff. So that is it. Speak to you soon.